how does the grid work, Michael?
The grid.
Yeah.
Well, the grid of yesteryear, I'll say, was very much centralized generation. Now, not only do we have power primarily flowing from A to B, we also have A to C to B to D to back to C to, it's flowing every which direction.
If you have a server farm, are you a farmer?
I would say no.
No?
Because he's a real farmer.
No?
I grew up on a farm. The next big thing eventually will be time of use energy. If I use it at this time, how much does it cost? California is already seeing it. My father-in-law has that at his house where if he hits a peak for a certain day of the month, he pays electricity for that cost for the entire month. It drove him to buy solar and battery storage on his house, and it paid itself back in a year.
Wow. If you had to put your money on the next 5 to 10 years, PV and BESS, our industry, where do you think things are going? All right, Sounds of Solar rides again. Sounds of Solar is back. Greetings and welcome. Your host, Christoph Bruhn, today. Joined with me, who are these people?
Russell Hamilton.
Prahalad, Shivshankaran.
And Russ is back. Russ, we missed you dearly on the last episode.
Yeah, but that last episode seems to be doing great without me.
Yeah, we did a lot of paid promotions. A lot of paid advertising on that one.
That's fair.
Yeah.
So Raj mentioned I was out in the mountains puking, and that definitely happened.
Yeah, that's...
I think a little altitude sickness maybe, but it was a lot of fun.
What were the key takeaways from your trip?
I should be living in the mountains. It's probably number one.
You can always just visit the mountains.
You can, but you can never replicate that elevation.
True.
That altitude, and it takes time to get used to it. So it took me some time to get used to it. Where I was staying was about 8,500 feet. And so the first few days...
Which is where? Where?
Conifer.
Conifer. That's a good mountain town name.
Yep. And then we climbed some mountains, climbed a glacier, St. Mary's Glacier. Put a picture here, right there.
Oh, that's the editing note.
That's the editing note.
Okay.
Yeah, no, it was a lot of fun. So yeah, it was cool. It was nice. And then Leo, shout out to Leo. He hosted me, and he built a sauna, and so it was like detached from his house, and so we were able to do that too. Go and sit in the sauna afterwards. There's a lot of
that's a day right there.
Yeah,
oh,
good stuff.
Great. Prahalad, what's happening in your world?
Not as much excitement as Russ here, but I did visit family in Raleigh, North Carolina. If I said it correctly.
Oh, yeah, that's right. I
time.
remember you have family out there.
Yeah, so did spend some time, a week there. So it was good catching up with them. They have 2 dogs, so I was able to pet them, take them for walks in the morning. I was doing 12,000 steps every day, so
There you go.
I'm kind of motivated to get a dog now. So.
Yeah. Raleigh is in the Research Triangle, right?
Correct.
It's Raleigh, Chapel Hill, and Durham, right?
Yep.
Yeah.
Did you go to UNC when you were there?
No, I wanted to, but we didn't get a chance. It just no agenda. We just went there just to chill with them. They have kids, so we just wanted to spend some time.
Yeah.
Nice.
So
Just
a
hanging.
chill week. Want to relax, not actually do any kind of hiking or anything.
Sure.
Every time we do something like this, we come back more tired, so it doesn't feel like a vacation.
Oh, I know. Well, you didn't take off. You got to take off that extra day. That's the
recovery day.
you have to.
Yeah. What about you, Chris? What do you got going on? Any gigs recently?
No gigs. So we are recording a record in February. That's lined up.
Do you have the name of the record yet? Or
no, God, no, too early. And yeah, we more performances coming up. Hopefully we have a winter fat biking. I was gonna try skiing this year too. We're still waiting on snow in Minnesota, so we'll see when that happens. But today we have a very special guest, the Director of Power Studies, Mr. Michael Carlson. Welcome to the Sounds of Solar podcast.
We need some
Clap track,
I slipped into my alter ego there.
I heard that.
For some reason, when I say your name, I just have to say it like that.
Okay, well, it comes naturally.
Yes.
Most people, yeah.
Welcome on the show. This is not your first time on the show, is it?
It is not, but it is the first time with you all.
Yes.
Yeah.
nice.
Yeah.
Yeah, the V2. Version 2.0.
That's right.
So, Michael, what's happening in your world right now?
Not a whole lot. Just trying to keep up with my kids, my wife, and get through what comes with year end and things like that at work. And so, just extremely busy and grateful to be here, I guess.
Yeah. How long have you been with EBS?
It is almost 6 years now.
6? That is like super veteran status in today's world.
Yeah, I think when I started, I was number 47, and now we're at 185-ish.
Yeah.
So, yeah.
Dang.
And tell us your background a little bit.
Yeah.
Who are you? What do you do on
What
EBS?
is it that
What do you do
around
here? Yeah,
here?
what exactly would you say you do?
Yeah.
Yeah.
I'm a people person.
So you physically take the reports to the customers?
Oh no, my secretary does that.
Yeah.
So yeah, I guess my bachelor's degree is in electrical and computer engineering from North Dakota State, and I've just been lucky enough to have a lot of different opportunities. Worked for a couple companies before I came here, and I've done business with not only like commercial industrial type applications, some campuses, electric co-ops, IOUs, municipals, but then primarily renewables for the last, 16-ish years now.
Wow. So you've been in renewables since like the dawn.
Like 2008, 2009.
Wow. Yeah. Okay. Oh boy, that is like.
But
that
you
long
started
ago, isn't it?
Wind,
I
right?
started in wind. Yeah.
Okay.
So I did wind primarily up until about 7 or so years ago.
Mm-hmm.
Was it offshore on?
No, all onshore. Yep. So all starting with about 1 megawatt wind turbines. Towards the end, there was the 2.5s and 2.75s megawatts, and then so wind. I did a couple of substation physical designs, and then a lot of distribution, some transmission, overhead and underground transmission line design through the years, and a lot of studies. That's why I'm the director of studies.
Very studious guy over here.
Yes.
Very studious.
So really quick, I was going to bring this up when I came back from my trip this summer to y'all. And actually, you just sparked a memory.
No pun intended.
When I was landing into Amsterdam, they have all of those offshore wind turbines.
Yeah.
And they're absolutely massive.
They're everywhere.
And
Yeah.
it was really neat to like see them. They're everywhere. So it was just really cool. I don't know.
And you looked at those out of the plane
Out of the
window,
plane
you were like,
window.
I'm thinking of Michael Carlson.
I was like, I wonder if Michael Carlson designed those specifically right there.
No international credentials.
And then you turned off airplane mode and texted.
I was like, Michael.
I got to talk to him right now.
Yeah.
Is each one like a megawatt, or each wind? I don't know what's the technical term. Wind turbine, wind farm.
Yeah. Each turbine, like I said, when I started, they were about 1 megawatt each.
Okay.
And then towards the end, the big ones were 2.5
Okay.
to 2.75 megawatts each.
And are they typically individual installations, or they do like a farm, or like?
They do a farm, so anywhere from 100 to, I suppose now they're much bigger, but I think the last one I did was 4 separate little farms that was actually like 650 to 700 megawatts that were all interconnected into the same substation.
Okay. Wow. So they do get pretty big.
Yeah.
So what do you enjoy doing more, wind or solar?
I mean, I would say solar, right?
Good answer.
He's paid to say that. He's paid to say that.
No, I mean, so I think wind was very interesting at the beginning. Wind kind of had its trajectory and it's really come up, and there's been the growth that's come along with it, and also, kind of the market share of who got into wind at what points and how much of the market share they took and things like that. To me, solar's been kind of like a very familiar feel in that sense then, because, it's kind of, I'm catching solar when I started kind of at that same similar trajectory where, lots of companies are coming in or taking market share, or, making those partnerships and things like that. And so it's, just like I said, feels familiar, but also very interesting in the fact that like you don't have the rotating machine. So you don't have the inertia from the rotating machine. It's all power electronics. So it's new, it's exciting. It's, as a technical engineer, it's very interesting from that aspect.
So currently director of power studies. Can you walk us through what maybe the last, it's been 6 years, right?
Yep.
What do the last 6 years look like in your time here? And, from where you started to now being director of the department, and how many people are under you now?
Sure. So I might get the years wrong a little bit. It's, not super clear, but when I started, ultimately I reported to Sohan, who's our VP now. And
was he VP then too? Or?
No, he was the director of electrical at that point.
Okay.
So, I came on board and they just needed a power studies engineer. And so I was looking for a change, and I came here and jumped in and did ETAP and brought up just all of our studies and models and things like that to kind of the standards I was used to, and helped develop that, I guess. And then from there, I was slowly built up to where I was a PM, and I was helping review all the proposals and contracts and things of that nature. then technical manager, or what did they call me?
Technical technical lead.
No, I think they were. I don't remember the exact name, but I think I was a team leader for a while, which I was maybe the only one at that point that
On the
had-
team?
well, no. We had a little bit of a team, a small team, but I think in the company, again, since we were small and we were growing, like I was the only one that was a team leader. And
So at that time, really quick,
Yeah.
when you came on, how big was the studies group?
there was myself, John Wadley was there, Sid had transferred over from PV and BESS. Rob Haroff has been here for forever, but he was kind of part of it, same as he is now, along with PV and BESS. And
Was Kurt here?
nope, Kurt was not here.
Okay.
So I feel like I'm maybe missing one other person that maybe was here but wasn't here for very long before they left
Okay.
to go someplace else. But
So
yeah,
small group,
there was
essentially.
maybe like
Mhm.
2 or 3 of us that were full-time studies
Okay.
all the time.
And now, what's the department?
And now our department is, I've been the director for a little over 2.5 years, two and a half years. And there were 26 people in the department with
That's
3 people already lined up for coming on board next year.
In January 2025?
1 in
Or-
January and 2 in June.
Nice. Oh, wow, June.
oh,
Damn. I don't plan anything that
yeah,
far
you
out.
guys plan ahead.
Well, I mean, that's where the industry is right now. And
We're gonna be
that's where-
busy.
Yeah,
We're
exactly.
going to be busy, and that's unfortunately when you go and talk to career fairs, the students are saying, "I'd really like to have my next place where I'm going to go after graduation lined up by November, December," and so
For June?
for June,
Oh
for
my
when they
God.
graduate in May, which is very different than when I came out of college. I was just 2 weeks before I graduated, I was happy to find
Same.
a job. So
Yeah.
There wasn't. Yeah, I was right after the OG financial crisis of 08, 09 and feeling the after effects of that. And there was not this job market where people are, I've got 5 offers.
yeah,
The job market's so hot. Like, no, it wasn't like that. So
definitely not.
different time.
Yeah, really quick. I know the studies is like a buzzword. What really comes under studies, and what was different in wind?
It's magic.
Is there?
It's
is it
just
same?
magic.
Have you heard of imaginary
magic?
numbers?
Yeah. It's everything's imaginary.
It's more of an art than a science. No, I mean, I think luckily a lot of it transfers over from wind. To similar to what we do in solar and BESS. The big thing I would say that's different, like I said, is the rotating machine aspect of it.
Okay.
There you really did have the turbine needed to spool down, and obviously there was some cutouts and they would shut off, before the turbine actually stopped. But I mean, essentially what we're doing is we're taking what you all do in the PV and BESS design team, where you're laying it out and you're saying, okay, this is what we need in order to hit our capacity factors and our, loads and whatever. And then we're looking at the back end of it and we're saying, okay, in order for this to work, because of these soil conditions or because of this temperature or because of this load factor or whatever the case may be, this is what size equipment you need. So you need this size cable, or you need to have a breaker that can, clear this quickly, or whatever the case may be. So that's
Okay.
It's kind of the back end verification of the design, but it also can very much impact the capital cost if we don't work together hand in hand.
So there's an iterative design process. Here.
Definitely,
Like you guys lay something out, you run the studies on it. Hey, maybe tweak this and this.
Yep.
They do it. Then you rerun the study until everyone is like, great. Everything's good.
Yeah, and just like with anything, right? You can do it 10 or 20 different ways, and
Yeah.
just trying to get to that point where what makes the most financial sense for whether we want to capitalize on the back end or whether we want to capitalize on capital expenditures. Who wants to make sure we save the most money when and where, but we always want to make sure that it'll be designed safely and appropriately, and so that's where we work together, I guess.
There it is.
So, yeah, it's the marriage of electrical and mechanical is what I typically say. So,
Yeah.
you guys do the electrical, we do the mechanical, and all comes together.
Yeah.
Don't worry,
Yeah.
we didn't forget you, but yeah, structurals.
Which goes into the model just the same. I mean, you guys even like consider the fence in the study, right?
Yeah, grounding
Grounding
studies.
studies. Yep.
Wow, look at
The fence, the piles, every piece of
everything.
metal.
Everything,
Yeah.
all pieces of metal.
So what is all the studies that you do? Ampacity, do you want to list them out?
Oh gosh, I'll probably forget some, but Russ can help me
I got
out.
your back.
It's not in the scope. If you forget it.
Ampacity, short circuit, reactive power study, loss study. Grounding is a big one. Harmonics, transient overvoltage, transient switching studies, transient recovery voltage studies, insulation coordination. Yeah, effectively grounded studies,
protection coordination,
protection coordination. Thank you.
arc flash.
Oh yeah, that's a huge one. Arc
That's a
flash,
big one. Arc flash.
AC and DC.
Yeah.
Then we get into
This is a lot.
Yeah.
I thought you were gonna have this like five. Like,
No.
pick your favorite one.
And then here's the fun
Oh,
part.
and then we get into substation, right? So
Yeah.
substation and grounding is a little different. Making sure that we do protection coordination work with the substation team and the PNC group. That's different as well. Protection coordination, PNC.
I thought it was project and wait. Am I thinking of a different
Projects and
PNC?
controls is one PNC, but in the substation world, PNC is protection and coordination.
And then here throw another wrench in there is each client wants different studies. They don't all want the same studies.
Oh.
So like they have different requirements.
And at different times, some will want it at 90%, some don't want it until IFC, some want it at 60%, and so, just a lot to keep track of on the front end with our proposals.
Yeah, I was going to ask you which are there certain studies that you do at a preliminary stage and some that you do post construction? Like,
Sorry.
No, you're good. You can jump
Russ,
in. You
you
know
can-
it as well.
Russ, you just get on.
I say
in
pretty
there.
much everything that we were doing is preliminary, and then we go to an IFC.
okay,
Yeah.
And then there are some post IFC studies that we'll do, like post energization harmonic study, or even like an arc flash study, maybe a post IFC.
Yeah. Sometimes like transient studies, we won't get the information that we need, or we won't get the breaker clearing times or the settings from the substation engineer early enough. So we'll run those post IFC just to make sure that we're using the actual information to make sure we're giving a proper assessment of it. But that's more of a timing thing than actually should it be run post IFC or not. It's just when we get the information in.
Okay. And one of the things I've noticed with a lot of these projects is there are some projects with substations, some without. Is there a big difference in how the studies team deals with these kind of projects?
Yeah, I guess for almost all of our utility scale projects, there is a substation that it's connected to. It's just whether we're doing it or someone else is doing it, and then, or maybe it's been pre-built and now we're just modifying it and connecting into it. So, but yeah, when we get into more of our DG type stuff, there's not a substation. It definitely impacts how we need to look at what the utility is beyond our own system, and is there a transformer, instead of a breaker, maybe we're using a recloser, which won't operate as quickly. And so, and there gets to be things like the utility might require us to have a grounding transformer there to make sure that we hold the voltages down. And so it does change what we do.
So talking about that, can you explain a little bit to the listeners about the grid in general? How does the grid work, Michael?
The grid.
Yeah.
Well, the grid of yesteryear, I'll say, was very much centralized generation. And so you had your coal plants, maybe you had your natural gas plants, your peaker plants, things like that. And you would have the energy there, and you would step it up to a high voltage, and you'd transfer it over transmission lines to wherever you needed to go to step it down to a voltage that then they could put it out to houses, businesses, places like that. The grid of today is very different than that. And, you have distributed generation on people's houses, on top of commercial industrial buildings. You have solar plants here and there and everywhere. You have wind farms here, all over. You have battery BESS storage, right? Backing up places where you probably never would have thought of having it before. And so now not only do we have power primarily flowing from A to B, we also have A to C to B to D to back to C to, it's flowing every which direction. And so not only is that a capacity management type thing, because again, if you think of it like a water pipe, water normally would flow just this way, and you'd release the valve and it would come out, right? But now you not only have pressure coming from over here where you're generating, but you have pressure from over here and you have pressure from over here. And one of the things that people don't think about all the time is that when you go through, like, let's say a distribution transformer, so you're going down to go out to people's houses, right? So you're at a substation. They look at it and they say, oh, distributed generation, we're going to put that on, this distribution feeder. That's going to overload our transformer. when you think about it from a pure number standpoint, you can make that case. But when you think about it from that power is not going to go anywhere unless it has a release valve, essentially, if you're using the water metaphor. So if there's a load out here and you're generating here and your substation is back here, if this power can come over here and be utilized, it's not going to come back through here. And if it does, you're not going to have power going this way to feed the load way out at the end and power going that's being generated back this way. You can't, go up and downstream at the same time, essentially. Yeah. And so that's where, some of the pure mathematical way of looking at things doesn't always make sense if you sit down and really think about how the power will flow.
So as we move forward into this grid 2.0, or maybe it's 3.0, I don't know, how does renewables impact? What do we need to change about the grid moving forward, or do we need to change a lot about it?
Biggest thing I think that, maybe is a struggle for a lot of people is protection. And it goes back to protection coordination is, not only do you have a single source now that's feeding out here, and if you have a fault or a problem in the middle, you need this to stop. And now you've stopped energy flow. But now you have 3 or 4 or 10 or 20 other places that are also feeding into that. Okay, you can open that up maybe, and you can still backfeed a bunch of other stuff and keep things on the grid. But now the way your energy is coming to that has changed. And so where you used to have a directional overcurrent element where you would say, if we're going this way down the line and all of a sudden our current gets too high, we're going to trip and open that up. Well, now you also have current maybe that's coming back the other way. And so if you don't update your settings, which obviously that's part of what everything that gets updated, but it just becomes much more convoluted than it used to be. So I think that's one of the big things. The next big thing eventually will be time of use energy, right? And if I use it at this time, how much does it cost? California is already seeing it. My father-in-law has that at his house where if he hits a peak for a certain day of the month, he pays electricity for that cost for the entire month.
Oh, wow.
And he's like, that's, it drove him to buy solar and battery storage on his house, and it paid itself back in a year.
Wow. 1 year?
1 year.
Wow.
Yeah. And so, it's just a little crazy to think about, but of course he got in before some of the new regulations and stuff.
Go back and listen to episode whatever it is with Bernadette.
Yeah. But obviously, those are the types of things that drive innovation when people can look at the numbers and just say, gosh, I can pay that back, not necessarily in money in my pocket, but by not paying extra money out of my pocket.
Exactly.
And so, it's a very different world. And, eventually when we get to the point where, well, if I want to charge, it's, my vehicle is going to be this much at this time of day, but I can charge it overnight at this cheaper value. And, also with, we're seeing it already with battery storage. If we sell it back at this time of day during the peak, we can sell it for a higher price than if we have to sell it back at 2 a.m. when nobody has their lights on. And so, it's going to get there. A lot of infrastructure is going to be upgraded.
That's what I was just going to ask.
A lot of transmission lines and starting with the high voltage, going down to the mid-range, all the way down to transmission, like subgrade transmission and distribution. Eventually, it's all going to end up getting built up in order to be a beefier backbone than what we have now.
Wow.
The biggest thing I was going to ask you was, how does renewables actually affect the grid? Like, what is the main problem with renewables? Maybe we can, I know we've spoken about how it doesn't impact firm capacity, but you can kind of talk about inertia. I know that's that fancy word that we talk about. So maybe you want to touch on that?
Yeah. So I think the biggest thing there, and obviously like a group of us went to the Minnesota Power Systems Conference this year, and they talked a lot about artificial inertia, and they talked about grid forming instead of grid following, inverters and things like that. But, the big thing is again, as we had these old coal plants, as we had these old peaker plants, whatever they were, they had the rotating machines. And so as the magnets spun, you had your 3 phases that were created, and you always had that, whatever we want to call it, you had that basis for your phase rotation.
Well, what is all that?
Sorry.
What are you talking about?
Sorry, structural guy. But so what it comes down to is as it spins the machine, you've got your magnets in there, and as they go around, they're creating your different waveforms.
Yep.
And so when you have A, B, and C phase, your 3 phases of power, they're all offset by 120 degrees from each other.
Sure.
Okay. So that's,
Why are there
that's
3?
inertia. Why are there 3?
It's efficient. It's the efficiency, the 120 separation also.
So 120 separation of 360 degree circle.
Yeah.
And then also when you put them close to each other, they'll cross off each other's electromagnetic
Sure.
forces.
It's like harmonics.
Yep. To some extent. Yep. So, but yeah, so obviously as you start retiring those plants, you start losing that inertia, you start losing that phase rotation, kind of like base load, baseline. And so now they're trying to find ways to use inverters that can not only follow what's already on the grid, but should they need to, they can form that artificial inertia for the grid.
Got it. So is wind better that way from an inertia perspective, or how is it different, I guess, wind versus solar?
We have a rotating.
You have a rotating machine, but it's still a power electronic in the top. And so I would say there's maybe some pros and cons to that. The pros are obviously, yes, you have some of that inertia effect and you can kind of go with that. The con is that you can't shut it off as quickly as you can with solar if you need to. Got it. So when you have a fault, there was a lot more high peak voltages that you would see, potential issues with over voltages and things like that at the end of your lines, because you'd see the peak and then it would tail down, whereas solar, it can react so fast, we hardly ever see that as an issue.
Okay. So when explain to the audience when something's over voltage, what's the risk with that?
Sure. So a lot of times, and especially what we do, everything is underground. So you put it on a cable. The cable has an insulation value on it, and so that insulation is rated for 100% of its 100% of its kV, kilovolt voltage rating. And so, all of them are rated per ICEA or whatever standard ANSI would, depends upon where you're at, I guess, and what piece of equipment you're talking about, but they're all rated. All of them can go over their voltage rating by a little bit for a certain amount of time, and they all have different curves, and we can compare those and look at them. But the big thing is that each time you go over that curve, you're essentially damaging it, and you can think about it like a fuse or a thermal capacity capability, so that the first time you go over, you're probably still good, but you've weakened or you've melted off some of that capability that you have, and each time you do after that, it might take a smaller amount before you're going to essentially melt off everything you have or make it pop to the point where you can't, and then you're going to get a fault. So not only will you have the fault where it originated at, which I don't remember the statistic, but it's a very high number of the faults happen at termination points for underground. So either, at the J boxes, at our elbows, at splice points, things like that. Or so you won't only have your fault there, but now you'll have a fault at wherever, usually arresters, because they're made to do that on purpose to take that extra voltage off and pop.
So explain also why, like splices, why are those hot points? Why are those terminations? What's the idea behind why is that the area?
The human factor.
The human factor.
It's the point in the system where someone has actually cut it back. No matter how well you train people, right? You cut it back, you have to fit it on there, you have to crimp it, you have to put, the reduction sleeve on it, you have to tape it off, you have to pull back your concentrics, it just, that's the place where there's the biggest chance of something going wrong. The rest of the cable, most of the time, has been inspected and
it's uniform,
designed, right? Designed, manufactured per the standards. And so unless you drop it into the trench and you hit a rock or something that potentially damages the jacket or the insulation, like I said, most of the time, splice or a termination is where you'll hit your high percentage of your faults.
But yeah, given renewables, have this impact on the grid, how do batteries help? Like, is it, if you could kind of talk about why batteries are sort of like a pro in this case? Yeah.
So batteries help a lot. First off, because their price of production is coming down so much that now they're becoming more economically feasible. But as we all know, the sun doesn't shine 24 hours in a day. So we can take that energy when it does shine, when we're at peak production, which also coincidentally, a lot of times isn't the time when distribution companies have a lot of their
Demand. Yeah.
right? And so now we're dumping that into a battery where we can store it. And now when people come home from work and are turning on their stoves and they're washing their dishes and they're washing their clothes and they're charging their cars and they're, everything else, now when the sun is going down and we're losing that production, or if the wind isn't blowing because we can't control the wind, unfortunately. So now we have those batteries there that can backfeed into that. And so where we've needed to have the base load before to make sure we covered all of that, because you just can't rely on solar, you can't rely on wind to always be there unless you have a huge amount of it. And then you can take into fact, like, well, no matter where we're at, somewhere it's going to be blowing,
Yeah.
So now batteries can essentially augment that. And so they're not base load per se, but they're acting like base load.
Okay. Interesting.
Is there a threshold we need to cross before we consider a PV and BESS installation to be like firm energy, baseload energy, or are we there?
Gosh, that's a great question.
That's why they pay me the big bucks.
That's right. That's why they pay you the big bucks. That's why they don't pay me the big bucks, evidently. I don't have the answer to that.
Dang it.
Yeah. I mean, I think the big thing is that the more of it we get on this out there, obviously the better it is, because the more just capacity we have. And so again, if something goes down, if we lose a breaker, if a cell burns out, if whatever happens, we just have more backup for that. Whereas unfortunately or fortunately, however you want to look at it, baseload has been tried and true. Like, it's just been there forever. Nuclear, water, hydro, coal, peaker plants, like they've been there, they've been around. People know they can rely on them.
And what is a peaker plant?
Thank you. I was just going to say,
Sorry.
you keep saying
so-
it. I don't know what the peak
Sorry.
is.
So a peaker plant a lot of times is a natural gas plant, and they only fire it up when they have a peak.
demand.
Mm.
Yeah.
So to manage peak management, they just will fire it up for maybe those 4 or 5 hours a day they need it, and then they can shut it down. And it doesn't have the same burn rate, or spool up time and things like that. That not nitrogen,
Coal.
nuclear. Nuclear, coal. Hydrogen, even hydro, right? Like, you have to make sure you have the capacity behind you. It takes a while to open the gates, let it come through, get it up to speed, whatever. So peakers, essentially, I don't remember what the time is on them, but you can bring them up to speed quickly to hit that peak load, so you don't see voltage dips and things like that.
Another general question about even the projects we produce, like, okay, let's say we have a 200 megawatt PV plant, and that's the peak capacity of generating capacity of the plant.
Yep.
When we do a PV and BESS project, is there a calculated, like, guaranteed minimum output because you have the modulation of the battery? Like, you can say this plant will always produce X number of megawatts because we will have stored energy in the batteries, or is that essentially just the battery rating, like the megawatt hour kind of thing?
Yeah, it's more so the use case of the batteries. So you could, if you wanted to, essentially like what you're saying, you could say we have a 200 megawatt plant. We know it will produce, from this time to this time during the day, it'll produce at least a minimum however many megawatts. During the peak, it will produce more. It will charge up our battery system, then we'll use the battery system once the sun goes down. The problem is that once the sun goes down, you still only have a certain amount of energy stored.
Yep.
And so if you want that to last the whole duration from dusk till dawn, you only can put out so many megawatts,
Right.
so that you hit your megawatt hour limit.
Mm-hmm.
And so usually, like I said, it comes down to use case. Most of them right now are, we're going to charge it when we can't sell back the energy, very good cost wise. And then we're going to turn around and discharge our batteries when we get the most back for them, which is, again, usually in the evenings when people are using a lot of energy.
It is a business at the end of the day.
It is. Yep.
So there you go.
And then to also guarantee that capacity, they do have the augmentation piece needs to be considered as well. So,
And then the difference between DC coupled and AC coupled BESS, right? So like that's the difference of when you're capturing that energy and how you're capturing that energy. So I was going to ask, what do you prefer, DC coupled or AC coupled BESS?
I think from like a coming back in and doing it after the fact, which is what we do a lot at the time, AC coupled becomes much easier to do because you can just hook it into the substation. You can do modifications to the substation, and now you have your own separate situation there instead of trying to go back in, trying to find the space in the field, trying to find the location where we can put the DC coupled batteries and things like that. Obviously, from a efficiency standpoint, there is probably some gains that you get by doing DC coupled. At least typically, we don't see as high of ratings, like megawatt hour ratings for DC coupled as we would for AC coupled. And again, that's probably just because of the amount of space it would take in the plant itself to do that.
When DC coupled BESS is done at the project development stage, is it always done in a per block basis, or is it usually a localized BESS yard? I just know because I know we were doing a project right now that has each BESS unit is located in the power block, and I haven't seen that yet before. And it is DC coupled.
That's
DC
what that's what DC coupled is.
Sure.
Yeah.
So DC coupled is you're coupled
It's behind
with
the
inverter.
inverter.
Where AC, you have a separate yard
Mm-hmm.
in front of the inverter.
I see.
There
There
I
it
suppose
is.
technically you could do a DC or an AC coupled in the plant, but it would be
Very
very
expensive.
expensive because you'd be decentralizing where you have all the battery storage containers at and things like that.
Mhm.
And from a logistics standpoint for like fire protection and things like that, it probably would be very not beneficial.
Yeah.
But yeah, with putting all these renewables, I think, on the grid, I think one of the big challenges we've seen policy people, everybody, like the industry, talk about is interconnection. And you kind of alluded to how the grid needs to go to like 2.0 or 3.0. What are some like future technologies that are being explored or future solutions that you want to kind of touch on that can help this problem?
Yeah. I mean, I think the big one is, again, BESS is the one where we're making the biggest, and long duration BESS right now is the big one that is going to help with, kind of to your point, Chris, of, do we have that base load? How do we meet the base load? Long duration BESS is going to help us get there. From a grid standpoint, really the biggest holdback right now is interconnection agreements and getting in the queue and how long the queue is taking to get through.
Can I just really quick, just repeat, because maybe people don't know what interconnection means. Can we just touch on what is interconnection?
Sure. Yeah. So when you go to your utility and you say, "Hello, Mr. Utility Man, I would like to put a PV plant out here, or a wind plant, or a battery storage yard, whatever," you have to provide them information on it, and then they will then take it and you get put into all of their queue for not only reviewing to make sure that it meets all their technical specifications, how it'll impact their system, what pricing is going to be associated with that. Will you meet their reactive requirements, things like that. So the interconnection agreement ultimately comes down to, will you be able to actually put what you want, where you want it, and that whole process goes through the utility, whether it's at the ISO level or, ERCOT does it a little differently, but they all have their special ways of doing it.
Essentially, they have their own studies team doing their studies.
They do, yeah. But just to like dumb it down, maybe it's basically making sure you can connect to the utility or the grid without causing issues to the grid.
It's the utility's essentially approval when you get your interconnection agreement that they will allow you to connect, and it won't have an impact on their system, negative impact.
Okay. Sorry, I just wanted to clear it up just in case. And then
that's good.
if you want to keep, you were going on good that I probably interrupted that. And
No, I don't even remember what I was talking about. But.
Technologies on how the renewables.
Oh yeah. So I know Prahalad, you've looked at it a little bit too, but the new FERC order that's coming out, that's gonna hopefully try and speed up that whole process and give a little more clarity and transparency into the whole thing and what the costs will be and timelines and things like that. So I think the last one got updated in like 2003 was one of them, and then they tried to do an update around 06 or 08, and then now 2023 is the latest one where they.
And what exactly is FERC order 2023? Does anyone know what FERC
stands for?
Federal Energy
Regulatory Commission.
There we go.
There it is.
Yeah.
Let's just run with that. Yeah, no, we'll get Jordan to fact check it.
Yeah,
Okay.
she's on it. Right.
Jamie, fact check
She'll
that.
put it right here. But I mean, ultimately, they're the ones who give the guidance on, what is best from an overall nationwide utility feasibility standpoint for the grid to be reliable for everyone, essentially.
It's interesting you talk, like we spoke about this earlier, like about transparency. Like Russ asked the question, what exactly does that mean?
Yeah.
Maybe you want to kind of talk about it, just because I know Patty Coleman, who we've spoken to before, highlighted how they've come up with a system about better payment for those upgrades so that they can kind of spread the cost. Maybe just touch on what really transparency really means. And
Yeah, and you know, obviously I haven't read all 1,481 pages of FERC Order 2020.
Only 1,400.
Only. But yeah, I mean, a lot of the consternation that comes from it, from people that try and put things into the queue, is that they'll put their information into the queue, they'll get it approved, they'll get information back that says, yes, you're approved, it will be $2 million worth of upgrades when it comes to your turn, right? We have to upgrade this line, we have to upgrade this transformer or whatever. Well, then maybe a year or two or whatever comes down the road when they're actually, their time comes, and then they'll get information. They'll say, well, these other 5 people in front of you dropped out. They were all on the hook also for another $5 million each for upgrades. Now you owe $20 million in order to make your project work. And there's, again, just not a lot of transparency in that whole process until kind of like your time comes up again. And so I think, from my understanding anyways, is to try and give a better, you know, outlook, level playing field, right, to people on that.
The grid upgrades are those charged to the project developers essentially?
Yeah.
So solely to the project developers.
Yep.
So what is the relationship long term? And I feel like we talked about this in another episode at one time, just about the relationship of like these quasi public private utilities managing infrastructure on the grid versus like, now people just privately build utility scale power. Like, where are we heading with all of this?
That's a great question. Yeah. I mean, it's ultimately who can get their projects through and who has the money and capital to build it. And I mean, obviously, there's regulations on how you connect things and what kind of cybersecurity you need and what types of metering you need and things like that in order to make sure it's secure and that it'll be there when it's called upon and needed, and that it'll have the reactive power capabilities you need in order to support the grid if you need to. And so they're trying to give like that set standard of these are the specifications you need to meet in order to be allowed to connect. But the problem is that, like I said, when people A, B, and C up the line from you say, no, I can't afford that anymore, and they were all going to pay for upgrades as well, now that person is getting the whole bill to try and upgrade it.
And that's like make or break. If they don't pay it, your project's going away too.
Right.
So.
And a lot of those projects, you know, if they're on distribution lines, let's just say, you know, if all of a sudden you need to upgrade 10 miles of distribution line to something much bigger than it is existing, that might kill the project altogether, because that upgrade cost is probably close to what you would want to do for capital for your DG project.
When the grid does need to get upgraded in this capacity, like you have an example, 10 miles, like what are the limiting points on the other end of that piece of grid infrastructure? Like, why does only this portion of the grid need to be upgraded? Is that like the thing you were saying earlier about, like, you got power coming in and it's going here, here, and here, and then that's all you need?
So the big one is conductor size, especially if it's overhead. Underground as well, I guess, is conductor, but you'll call it cable if it's underground and it's insulated. So, you know, a lot of the distribution system that's out there right now was built in. I mean, gosh, I've gone and done inventories of towns in Iowa that those poles were put up in 1910. You know, so they're old systems, and they might be a number 6.
The cables aren't that old, right?
Right. No, they might be.
Oh,
a lot of them are. Yeah. I mean, they're copper. They're good,
I suppose. But they can handle.
Well, and that's the problem. So they can handle the load for what it is right now. But if all of a sudden you have your substation and you have 10 miles, let's just say, out to this point where you can buy the land or find the land and lease the land and whatever, it might only be rated for, I'm just going to use a number, let's say 400 amps, right? Which is probably pretty high. You know, maybe let's say 150 amps. Okay, it's rated for 150 amps. Well, now if you want to put 20 megawatts out there, you're far exceeding that 150 amp rating. So now in order to connect from here and potentially sell back to the utility when no one uses any power out on there, you need to rate that line for 400 amps, or 20 megawatts.
Yeah.
I don't know if it's 400 amps, but so now not only are you upgrading the conductor to make sure it's sized, but now the poles aren't ready for that kind of weight. So now you're upgrading the poles, and if you can run old wire that's really light, you might be able to run it 350 feet between pole spans. Well, now it's heavier, so now maybe you can only go 250 feet between pole spans, and now you're adding that many more poles, and it just compounds. And then you get back to the substation, and again, depending upon the sub and how old it is, maybe that's not rated to have that much power coming back through it. So now you're talking about a transformer for the utility
And a breaker.
And so I mean, that's where it can get very expensive to do.
So this is why we're looking for transmission lines engineers.
That's right. Overhead line.
Overhead line.
Yeah, it seems like all these are just stopgap measures until we have to just upgrade the grid, which is, I think the options floated around are like 765 kV, HVDC.
Yeah.
We want to kind of talk through just...
These are different, different standards of high voltage transmission.
Very, very high voltage transmission.
And what is the current?
So right now, like if you see
standard?
a 500 kV, that's that's a high voltage, extra high voltage transmission line. Like you said, 765 is out there. HBDC, I know there's one that runs from North Dakota over here into Minnesota. So HVDC, the big thing is the distance wise, you can run it very long distances and have less losses than AC. You lose the efficiency on the conversion stations on each end. And so essentially it has to be over a certain distance, and I don't remember what that is off the top of my head, but it has to be over a certain distance before it actually makes feasibility sense to do that. 765, obviously, the higher you go in voltage, if you do the old electrical calculations, that drops your amps down. And so now if, let's say, your conductor is rated for 200 amps, well, if you're going up in voltage, that same 200 amps can give you that much more power. So the higher you can go up in voltage, the more power you can push across with the same number of amps.
So is this like a Betamax versus VHS or
similar?
Or in the modern world, not modern, slightly less vintage world, was it Blu-ray versus
just HD DVD?
HD DVD?
Yeah.
Well, they lost because it was a bad name.
I thought you were going to say DVD versus Laserdisc.
Oh.
Yeah. 8-track versus...
Laserdisc didn't make it very
tape
far.
deck.
Yeah.
So which one is your preference if you had to pick one?
I mean, HVDC has been around, like I said, that
it's actually HD DVD.
Yeah.
Sorry, you had that wrong.
Thanks. But yeah, the HVDC line in North Dakota, across North Dakota to Minnesota, has been around for, 10, 15 years, I think. It's like I said, for the right amount of time of distance and conversion factors and stuff like that, it's a very good system. The problem is you can't tap off of it. You can't, it has to be kind of like a point to point type of connection. And so from that standpoint, it maybe falls behind, unless you're doing like a direct link connection between let's say a Denver and an LA, a generation point and a huge load center that's a sufficient distance away. You lose that capability to tap off and either bring in more generation or sell some power or do that. Whereas 765, is, you're not going to do a lot of that, I would say, just because, again, the capital cost to do it, but it leaves you the opportunity to do it.
Okay.
So with all our sources being DC, I'm just curious, maybe just plug in all the solar just directly.
But everything that we use is AC. It's like all your appliances and everything.
Yeah, but I mean, you look at like server farms, right? They're all DC, and so DC. If you could go DC to DC, it's
efficient.
If you have a server farm, are you a farmer?
I would say no.
No,
because he's a real farmer.
Yeah,
I grew up on a farm.
Yeah,
he's a real farmer.
Former farmers, a real farmer. Yeah. Former farmers of America.
That's right.
It's a different FFA.
That's right.
Yeah. So Michael, if you had to put your money on next 5 to 10 years, PV and BESS, our industry, where do you think things are going?
I mean, I think it's going to continue to grow. I think it will see, I won't say a slowdown. I think it will. The the crazy parabolic growth that we've seen, I think we'll start to do one of these, and we'll level off a little bit more. There'll still be a good amount of growth. I think the fact that BESS is coming on strong, the BESS portion will see the more parabolic growth, and PV will kind of follow what wind has done, whereas it's continuing. It's, continues to gain market share, but it's not as crazy as it has been in the past.
We've kind of figured PV out relatively
right.
to 3, 4, 5 years ago.
Yep. So then the next big thing will be obviously, long duration BESS or
Perovskite.
Perovskite. Someday.
Just have to put that in.
Someday.
Brody loves that word.
Yeah.
But are you familiar with perovskite? Do you have any bets on that technology as far as where it's going?
Even is.
Tell him, Brody.
It's basically like we know that the
Here we go. No, it's Prody's
sun
show.
is super powerful. And
Super.
powerful. No, basically the PV panels, although they have like when we look at the efficiencies, they're not really that efficient because there's so much more of the spectrum that's available.
Yeah, what do we say? They're
Perovskite.
like 15% or something.
I think 30,
20.
I think the record right now is in the low 30s. Well, there's always PV Magazine is always like new efficiency record. It's like every week. It's
But essentially, they've found like material that can absorb the latter half of the spectrum, so you can kind of get better, improved efficiency overall. So, and then now there's something called quantum dots. I don't know.
quantum dots.
Quantum dot solar cells. So
Sounds
we
like a
think we
breakfast
figured
cereal.
out PV, and then suddenly, we're seeing crazy amps, and
Yeah.
and then the studies team needs to hire 10 more people, and
Yeah. It's just a good thing.
That's what I was gonna say. Is like you're talking about like the level up, but I wonder if like when the technology keeps improving, if it's gonna, I don't know. Maybe it's just because more efficient. What's that gonna look like?
Yeah, I mean, I don't think renewable energy will level off necessarily. I think PV,
Oh, sure.
to some extent, will, and again,
It's
level
got to
off
eventually.
might not be
Yeah.
the right word, right? It'll continue to grow, but just like what market share will it continue to hold on to? Obviously, as we have new technological developments, as we have new things that come out, desalination, wave technology, things like that.
Which is my favorite.
That will all gather in and take part of that market share, right? And so there will be many different ways that we get renewable energy, but it'll continue to grow.
Well, it is a supply and demand thing because I think numerous sources that I saw recently are citing in the next 3 to 5 years, power consumption demand is going to double. Double.
Is that because of all the EVs?
I don't know. Maybe
data centers coming online.
And the data
everyone's going to have
hyperscalers,
2 phones
AI,
at the same
AI.
time, 2 computers.
Bitcoin farms.
You're going to be using Apple Intelligence.
California is requiring people to only buy electric vehicles here in a couple of years.
For 20
Yeah.
right?
Well, there's like a
It's
huge
2030.
ripple effect because of that.
No,
And also,
new. You can't buy anything new.
Yeah, because that's also going. The big effect that's having is the commercial freight train industry, right?
Yeah.
Because they're mandating freight trains are also have to comply with that, which is really complicated because like ports like San Diego and LA are like the main ports for the Pacific Ocean, and it's like all trains that go in the U.S. go to California. So there's a whole thing happening on that.
Maybe
side,
in the future they're going to go to work.
Maybe we're gonna have to build electric trains. I think also.
Then we'll be electrical engineers.
Yeah.
The people who drive them will be electrical engineers.
Oh, look at that dad joke. Love it. John Barger would be very proud of you.
Yes, he really is. Okay, one more final question. Michael Carlson, dad from down under. Actually, you're from up north in Fargo.
Yeah.
Did you grow up in Fargo?
I grew up north and west of Fargo, about
In
90
Minnesota
miles.
or
North Dakota.
North Dakota.
North and
So
west,
yeah,
yeah.
I used to play. I grew up north also in Park Rapids, which is
Oh, nice.
lakes
Yep.
country for
Yep.
Fargo
Lakes
was
country.
always a town. I went school shopping.
Yep.
Went to West Acres Mall.
Yep.
Yeah.
You know.
You didn't go to the Moorhead Mall? The Moorhead Center Mall?
No.
There's no sales tax.
No sales tax on clothes in Moorhead.
Yeah.
Really?
Oh, really?
Yeah.
Oh yeah,
Minnesota.
duh. I knew that. Yeah.
Minnesota.
Well, no, we didn't. The selection was better. I went to PacSun.
All right.
PacSun.
I know. I was a skater
So
boy.
on brand. So on brand.
And I used to play hockey up in Kitson County. That's probably kind of close to where we're Hallock.
Oh, I know.
That's
Way up
still
there.
Minnesota. Yeah.
Yeah, but we didn't go to North
That's
Dakota.
way north, farther north than me.
Okay.
So I was like,
Thief River Falls.
No.
You know,
So
okay.
Hallock, when I was doing road construction, I actually did 2 of their highways in Hallock.
Really?
I spent the entire summer
Yeah.
there.
Yeah. So their ice rink was a literally a barn that it was just big enough to fit the ice rink and like 2 bleachers.
Nice.
And that was it. It was, anyway, what's the part of the show we're at now? Oh yeah.
Final question.
Yeah, final question. If you could give one piece of advice to someone, whether they're a young grad, experienced professional, someone coming into renewables, solar, what would that advice be?
Yeah. I think my piece of advice is usually the same to everyone, and it's, take every opportunity you get, soak it in, learn, drive, use your drive that you have. I often say that when I do interviews, I know within 5 minutes if I'm going to hire somebody, because if they come prepared, they come with drive, if they've done their homework, like I just know it. And so just, there's so many parts of my background that I still use almost every day, but aren't solar, aren't wind, aren't substation related, but they all have made me who I am. And so, yeah, I mean, it might seem like something trivial, or it might seem like something that doesn't make a whole lot of sense or isn't going to progress you, but take the opportunity if you're given the chance, and maybe you'll learn something really cool out of it, or use it in the future to, make yourself better or something like that. So, yeah, it's just, use the gifts you've been given, and I don't know, do the best you can.
There it is.
Nice.
It's skill stacking.
I was just gonna say that. Skill stacking.
Skill stacking. A little bit.
You guys know your fancy words.
It was
I'm just like, do the
previous
best you can.
guest.
Previous Logan, right?
No,
Michael. My bad.
All right, that's okay.
Skill stacking.
Skill stacking. All right, from all of us at the Sounds of Solar podcast, we've got Proddy, Mikey, Rusty, and Chrissy here. Thank you so much for listening, tuning in, however you do it. See you next time. And also stay tuned early this year for the special Directors Roundtable discussion. All right, we'll see you next time.